Hello friends, today we're going to solve trailing zeros problem. So our task is to calculate the number of trailing zeros of a factorial n. So trailing zeros is nothing but how many zeros are left of an n factorial number. For suppose here n is equal to 20 and this 20 factorial have this is the result of 20 factorial, and as there are only 4 zeros are present at the end of the number. So the answer is 4 trailing zeros. I think you understand what do you mean by what's the meaning of trailing zeros. So yes, input is just we have to read one number, and output we have to print how many number of trailing zeros does the number have. So and this is my code. Before going that, we have to understand insight of this problem. This is sorry. Okay. So for a number, like if I take if 5 factor 5 is a number. Okay, if I take 5 is my number, so like then 5 factorial is going to be 1 into 2 into 3 into 4 into 5. Isn't that right? So how many number of zeros are present at the end of these number? 1 and 2, 6, 24, 24, 5, 20, 24, 5, 120. So yeah, 5 factorial value is 120, right? So 120. There is only one trailing zero is present for the 5 factorial. So um, here the brute force approach is we have to find the factorial. We have to write a code for factorial, and then we have to find how many zeros are left at the end of that number. So it is just as simple. We have to divide that number, divide the factorial number with the zero until we get uh, a non-zero value. We have to increment our result value, and then we have to send our result value. Yeah, that is the result value. So here the time complexity is n s n into n, it is 2n. So because first we use a big of n for finding the factorial number, so for factorial it has to take n, and for finding the zero on the trading zeros, it's going to take another big of n, so total big of 2n. So but here there is a hint. So for factorial, like if I take a 10 factorial, so 10 factorial is equal to 1 into 2 into 3 into 4 into 5 into and so on into 9 into 10, right? So 9 to 10. So here the zeros are 1, here 10. Already 10 has a trailing zero, 0. So if any number is multiplied with 10, that number has to be end with 0. So here our trailing zero must have 1 0. It must have 1 0. At least must have 1 0. And the other zeros, but the result of 10 factorial. So, what is the 10 factorial value? So 5 factorial is 120, right? So 120 into 120. So we got two trailing zeros, 1400, 1000, sorry, 14,400. So it has two trailing zeros. So 10 factorial have two trailing zeros. So one zero it already have because it has a 10 as a number, and other zero. So we have to multiply the first and last digit of simultaneous values. But we must get 1 0 from those multiplications, like 1 into 9, 1 into 10. So I get 1 0 already, and now 2 into 9, 18. No, it's not going to work. 2 into 8, 16, not going to work. 2 into 17, 14, not going to work, and so on. 2 into 5, so we got 10. So here these 2 and 5 numbers generate another 10, so which have 0. So that's why these 10 factorial have two trailing zeros. So for finding the trailing zeros, we have to find how many twos are present and how many fives are present and how many tens are present. So we may forget. It's no need to find how many tens are present because 2 into 5. Yeah, we can split every 10 into 2 into 5 also. So uh, I'm gonna say we have to find only how many fives are present in n factorial because uh, if you take 10 numbers 1 into 10, so every second number after the number 2 is going to be multiple of 2. So that means we can write 4 as multiple of 2, 2 into 2, right? And 6, we can write multiple of 2, right? 2 into 3, and then 8, 2 into 4. So, but 5, with 5 number, we can write only the of 5 digits. I mean, we can write only every 5 digits after these 5 number as like not a 5 number, 5 numbers after these 5 value is a multiple of these 5 number, right? So I mean here this is 5, right? So the number after 5 uh, 5 times of this number is 10. So we have 6, 7, 8, 9, 10. So after these 5 numbers, we can get 10. So which is a multiple of 5. That's what I want to say. I think you understand. So for finding these, how many fives are present in n factorial? So we have this formula. This is the formula for finding how many fives are present for n factorial. So and why I'm writing this, so it's gonna make you understand a simple logic. So 1 into 5, 5, 2 into 5, 10, 3 into 5, 15, 5 into 4, 20, 5 into 5, 25. It's quite simple. But it's just a multiple. But how many 5s are present in 1 into 5? Only 5. And 2, 2 into 5, only 5. 3 into 5, only 5. And 4 into 5, 5. But 5 into 5, there are 2 5s are present. So just like that, 6 into 5, only one 5 is present. 7 into 5, only one 5 is present. 8 into 5, only one 5 is present. 9 into 5, only one 5 is present. But 10 into 5, we got two fives. Like 5 twos 10 into 5. So two fives are present. So every multiple of a 5 has two fives other than other multiples of fives. I think you understand. So and this formula is succeed to find how many fives does n factorial contains. So let us going to see the code and how it's work, how I actually use that formula in my code. So here I'm just reading the integer number from the user. So I'm not gonna find factorial of this number because it's going to make a big like it's going to make a high time complexity. And here the yes, our denominator is 5, and I initially take r is equal to 0. So result is equal to 0. Only one zero trailing zeros are present at the end of the uh, n factorial number. So here this is the logic. You see here. Okay. So n divided by, so first I make sure that if any number that given n number is actually a divisible of 5. For suppose if I give you 3, 3 divided by 5, um, 3 divided by 5 is actually gives a greater than 0 value, right? So because the result of 3 division by 5 is equal to 3, right? So 3 is actually greater than 0. That's why I'm not actually increasing further. When 3 divided by 5, the result of the division is 0. The remainder value is 3, but the coefficient value is 0. So which is not actually greater than 0. Understand? So we treat this is a remainder symbol and this is a division symbol, right? So for this I get 0, which is not greater than 0. Why the size is that actually changing? Okay, so it gives me value 0, so which is not equal to 0. So when I get 3 factorial, it doesn't have any trailing zeros. So, but when I get 5 factorial, I get trailing zeros now. So let us check. 5 divided by 5 greater than 0. So yes, right? So 5 divided by 5, the coefficient value of this 5 divided by 5 is actually 1, which is 1 greater than 0. So as this condition is true, we have to increment our result value. So we can simply increment our result value as r plus plus. Why I'm writing this is because uh, whenever I get more than 20, like 28, if I get 28, I get actually two fives. In 28, I actually get two fives. Like in 25, I get actually two five, right? So more than 25, I also I get two fives, right? So in this 28, when it is divisible by 5, I get 5 is 25. So I get 5, which is greater than 0, which is greater than 0, right? So 5 is 25, which is greater than 0. We don't need to discuss about the remainder here. Okay. So 5, which is greater than 0. Now I'm actually adding that 5 result to this R. Why? So think about, come to this place here. So 1 factorial is already have 5. So if I have 28 as a number, divided by 5 sets, like in 28 I get 5 5 5 5 5, like it's been kind of confusing, but it's not. In 25 we have 5 fives plus 3 value there. So because 5 5 is 25, so it actually have 5 values. So that's why, as it have 5 5 values, I'm actually adding 5 as to the result, because how many number of fives is actually directly equal to the how many trailing zeros are present. Because I'm actually not bothered about the 10 here, because I write 10 into 5 into 2. So which is again I have to calculate how many fives are present. So understand. So that's why I'm writing n divided by 5 here, and 5d into 5. So why d into 5? It actually increment the denominator value. So in this formula, if you check it here, so the denominator of every time it's multiplying, it actually incremented to 5 times. So like here, first time it only 5. So second time it actually for 5s. So third time 5 cube. Fourth time 5 into the power of 4, 5. So just like that. So whenever the remainder is less than or equal to 0, it actually came out and print the result. You see. So for suppose, let me check. Let me take 20. Okay, 20. Okay. Wow, this is great. 20 divided by, okay, first, okay, 20. If I give input is equal 20, 25 by 5, which is equal to 5 5, no, 5 4 is 20. So 4 greater than 0. So that means these 20 factorial must contain four trailing zeros. We don't know it exactly contains four trailing zeros, but it must contains at least four trailing zeros. That's why we are adding in this 4 to the result. So I'm adding that 4, and then I'm incrementing my denominator, which is equal to 5 into 5. So which is our denominator becomes 25. So now it's going to this process is going to repeat again. So our input value is it change? No, 20 by 25. Now it gives the value 0, right or wrong? So whenever the denominator is more than the numerator, obviously we get 0 as the coefficient. So is 0 greater than 0? No, it's not. So then the loop breaks and came out, it prints R value. So here, what is R value? We get R value as 4. So this 20 factor exactly contains 4 trading zeros. So this is just a like a mathematical equation. But if we are not discussing, if you are not think up to this thought process, if we are not capable of thinking up to this thought process, we we can solve this problem with reverse approach. Like we have to find the factorial of this number.